So I did not send out a video. I didn't record how to do example 7 here. Got busy, had a couple things I had to get done yesterday and didn't get that finished. So what I did ask you to do is just kind of look at the notes and that sort of thing. So let's just run through really quickly what we were talking about yesterday. We were talking about rational functions, and we're going to be able to graph these, but we need kind of some basic information first. We talked about what a rational function was, that it's one polynomial over another polynomial. So it's got division in it, and we talked about how these types of graphs have asymptotes on them, and an asymptote is a line or a curve that approximates the graph. So it helps us make the right shape. And most of the time we're going to have a vertical asymptote, or maybe a couple of vertical asymptotes, okay, and a horizontal asymptote. And a lot of this question of graphing these revolves around two words, proper or improper. Pretty easy to figure this out. It's going to be proper if the top is a lower degree than the bottom, and if it's improper if the top is the same or a higher degree. And then we've got a good type of improper and a bad type of improper. So the cool part about this is finding the horizontal asymptotes is relatively simple. Okay, if it's proper, then it's y equals 0. If it's improper, then we have to ask ourselves, is it the good type or the easy type of improper or the bad type? If it's the good type, then the top is exactly the same degree as the bottom, and then it's going to be the leading coefficient on the top over the leading coefficient on the bottom. Okay, if it's the bad type of improper, the reason we call it the bad type is because you've got to do long division. It's a little bit more difficult to find, just slightly, but it's actually kind of nice to have a slanted asymptote, or what we call an oblique asymptote. Okay. And I'll show you why. So we went through and we did a couple of examples. We found the horizontal or oblique asymptotes. We found the vertical asymptotes in the holes. Remember, these all have domain issues, or nearly every one of these have domain issues. There are numbers that you can't plug in because we can't divide by 0. If that problem in the domain cancels, it becomes just a little hole in the graph, just a little dot that's not there. Okay? If it sticks around, then we have what we call a vertical asymptote. Okay, and we talked about how we usually want to graph the intercepts, the x and the y-intercepts, and we talked about how to find those. To find the x-intercepts, we usually use the simplified form of the rational expression. And then we went through and we did a little bit of matching, okay, and kind of went through and explored, okay, if this was the rational function, where would be the vertical asymptote? Well, the vertical asymptote would be at the number that you can't plug into the denominator, and that's -4, okay? And then we also figured out that it has a horizontal asymptote of y equals -1. So we came up with this graph right here, and then went through and explored those other ones. Okay, and then where we left off yesterday was on this right here, and this looks like a ton of information. Okay, turns out that it's not that bad to go through once you get practiced at it. And we will have a test on this next week. You'll have some graphs where you've got to do this very thing, and some where we just some problems where you just do parts of this, but we're going to put all these pieces together. So I'm going to leave this about right here. I'm actually going to try and make this just a little bit smaller so we can see the whole thing. Okay, so the first thing we're going to do when we graph this, so pick up right here. We've done a lot of thinking so far today. Pick up right here and let's start graphing this. The first question is, and we've looked at this one already, is this proper or is it improper? This is proper. Okay, so because this is proper, that means we're going to have y equals 0 as a horizontal asymptote. Okay, there's our first piece of information. Now, if you want, you can go through and you can draw each piece as you get it. So if we want to, and I'm going to do this in red, I can come here and I can draw the horizontal asymptote of y equals 0. So that's right along the x-axis. And I'll write y equals 0, and I'll label that HA for horizontal asymptote. Step 1's done. Okay, step 2, factor the denominator to find the domain, okay, and then factor the numerator and cancel any common factors. So we're going to take this, and I'm going to change colors here. I'm going to write this as x minus 1 on the bottom, and x plus 1 on the bottom. Okay, so I just factored that difference of squares there. Okay, what number can I not plug into this factor right here? Okay, this is going to be x equals 1, right? What number can I not plug in here? X equals -1, right? Okay, now do either one of those cancel? Okay, I can cancel this x minus 1 with that x minus 1. So because this cancels, this becomes a hole. Remember, we did this very problem yesterday. That one's a hole because this one doesn't cancel. What's this? Vertical asymptote. So I'm going to put a circle around the two of those. Okay, and that means the simplified version is a 1 on the top and an x plus 1 on the bottom. There's the simplified version. So let's come down here, and I'm going to do this in red again. So I've got a vertical asymptote at -1. So here's -1. So I'm going to draw a big, long, dotted line, big vertical line. And I'm going to label that as x equals -1, and that's the vertical asymptote. And here's how we take care of holes. And remember, this textbook doesn't have you work on any holes, but I want to show you what these are so that you're ready for 1050. Okay? I draw a short dotted line and just write the word hole by it. We've got a hole right there. Okay? All right. Any questions? Okay. The next thing we do is we're going to find the x and the y-intercepts. So I'm going to make a little xy table. I'm going to plug in a 0 for x. Now I can plug it for the y-intercept. I can plug it into the original one or this one right here. It doesn't matter. If I plug in a 0 here, I get a -1 on the top. Plug in a 0 here, I get a -1 on the bottom. A -1 over a -1 is a +1. Or if I plug it in right here into the simplified version, there's already a 1 on the top. And what happens if I plug in a 0 in the bottom? I still get 1 over 1, right? So the y-intercept is 0, 1. So I'm going to come over here and I'm going to put 0, 1 right there. There's the y-intercept. Okay, I've got that point. Okay, now I want to find the x-intercepts also. So I'm going to plug in a 0 for y. Now remember, we use the simplified version, so don't use this one right here. Let's use this one right here. I'm going to set that equal to 0. Okay, and we had this huge advantage when we're working with a rational expression. What's the only part of a fraction that can make the whole thing equal to 0? The numerator, right at the top. Okay, so on this problem, does 1 ever equal 0? There's no variable in the numerator, so there is no x-intercept, okay, or none. Okay, doesn't cross the x-axis, doesn't touch the x-axis at all. And that's actually a huge piece of information. Okay? All right, any questions there? Okay, so we've found the horizontal asymptote, we found the vertical asymptotes and the domain issues, figured out whether or not we've got vertical asymptotes or holes. And I've got one point that I know is on the graph, 0, 1. Okay? The next thing we do is we draw all these on there, which I did at the same time. And then we're going to use an XY table to figure out where the graph is above or below the x-axis, where it's positive and where it's negative. So let me show you how to do that. Here's how we're going to look at this. Okay? This right here is a vertical asymptote. Okay? There's nothing else, no holes or no intercepts or anything like that that happen over here. So what we want to do is we want to pick a point. So pick any point you want that's less than -1. What would be an easy point to plug in? -2. Okay, so on the XY table, we're going to plug in a -2, and let's figure out what we get. Now let's use the simplified version. So this is going to be 1 over -2 plus 1. That's 1 over -1. So what answer do I get? I get -1. Okay, so at this point right here, at -2, the value of the function is -1. Okay, now rational functions are made up of what we'll call branches. Okay, now the reason we drew this horizontal asymptote here is because out on the end it looks like this horizontal line. It runs along here. Okay, then it's got to hit this point right here. So can it do this? Everybody watch, please. Can it run along here and then go through that point like this? Why not? Okay, here's the big thing. There are no x-intercepts. So if I found a point that's below here, this entire branch, this entire piece over here is all below. So it runs along here, below there, and it hits this point right here. Now remember, when it approaches a vertical asymptote, it's got a choice. The reason we have that vertical asymptote is because it's either going to go up right next to it, get really steep, or it's going to go down next to it, get really steep in the negative direction. Okay? So, can it do this? Why not? No X-intercepts. Hi. That's okay. Okay. There are no X-intercepts there, so it can't possibly do that. So when it gets close to this vertical asymptote, what's the only choice it has? Which way's it got to go? It's got to go down. Okay, so we're going to draw the rest of it and we're going to go down. Now, whenever you've got an asymptote, whether it's a horizontal or a vertical asymptote, you want to go right next to it here and then go down, go right next to it here. Don't do something like this and kind of keep it away from it. Get it right close to it. Okay? Now, if we're going to be convincing on a test, we want to show that we know what we're doing here. Let's go ahead and label this point. This point is -2, -1. Any questions there? Okay, now, anytime you have a vertical asymptote or a hole, anytime you have a domain issue, that's going to give you a little interval on which you want to pick a point. Did we already pick a point in between the vertical asymptote and the hole? We did, okay? So is there any way this graph does this? Okay, you're going to get sick of hearing this. Why not? There are no X-intercepts. It can't possibly go down. So its only choice is to go up, okay? And there's no X-intercept here, so I'm going to do something like this. Okay, again, get right close to the vertical asymptote, draw an arrow on the end. Okay, now, it is possible, although unlikely, that that hole is right here, and then it does something like this. It's possible, but it's unlikely. So here's how we tell. Does it do this, okay, kind of skip the x-axis, have a hole right there, and jump from above to being below, or does it continue going on like this? And is it all above? How do you think we find out what it looks like over here? Yep. Okay, if we plug in a 1, okay, remember, you can't plug in a 1 right here. You could plug in a 1 right here, okay, but that's not going to be a point on the graph because we've got a hole right there. Let me show you what happens if you plug in a 1 in just a second. Usually it's a good idea to pick a point a little bit past there. So let's pick a point over here. Let's pick 2. If you plug in a 2 into the original one or into this one right here, what do you get? 2, 1/3. Okay? So is it above the x-axis or below the x-axis? It's above. Okay? So it does look something like this. So let me get rid of these guys right here. So this point right here is 1/3. So 2, 1/3. I'll label that, and we'll label this one right here. And it must do something like this. So put all the information, draw a sketch. What does each piece of information tell you about the graph? What is an x-intercept? It's where it hits the x-axis. What's an asymptote? It's a line that helps us approximate the curve. Okay. What does the multiplicity of an x-intercept? We didn't have any on here, so we don't have to worry about that. Okay, now let's come back to Peyton's suggestion about plugging in a 1. Okay, you cannot plug a 1 in here, but you can plug in a 1 right here. If you plug in a 1, what would you get? You get 1/2. So guess where this hole is? How high above the x-axis is it? It's at about 1/2. Okay? That hole is located at 1, 1/2. It's not a point on the graph. You can't plug it in there, but that's about where it would be located. So if you did plug that in, taking Peyton's suggestion, and you got 1/2, you know that this is above the x-axis. So this branch is all below. This branch comes in 2 pieces. Okay? Or you could say it's 1 piece with a little hole in it. Okay? And this graph is either all above or all below the x-axis because there are no x-intercepts. No x-intercepts. If there are no x-intercepts, that is a gigantic piece of information. Okay, any questions there? Okay. Does that look too bad? Okay, they take some time, but they're pretty step by step, and each step is relatively easy. So let's flip the page over. And we're going to run through another one. Okay, same type of steps. So, first question is, proper or improper? Which is this? This is proper. This is proper, so y = 0 is a horizontal asymptote. So I'm going to come over here and I'm going to draw a horizontal asymptote right on the x-axis, and I'm going to label this. Y equals 0 is our horizontal asymptote. Next. What is that, Sven? Factor the denominator. So we're going to factor this. I've got a 2 and then an x minus 3 and an x plus 3. Okay? So remember, those factoring problems never go away. We got to keep track of those. And then we figure out what we can't plug in. What can I not plug into this? 3 and negative 3, right? Do either one of them cancel? They don't. So what are both of them? Vertical asymptotes. Both of these are vertical asymptotes. So I'm going to come over here and I'm going to draw a vertical asymptote at 3, like this, and a vertical asymptote at negative 3, like this. And I'm going to label each one. So this is x equals negative 3, vertical asymptote. X equals positive 3, vertical asymptote. Now, let's say each one of these is worth 10 points on the test. Maybe 3 points so far? Pretty easy so far, right? Okay, what do we do next? Intercepts. Okay, we want to find intercepts. So I'll make a little XY table, I'll plug a 0 in, and it doesn't matter whether you plug it into, there's really not a simplified form. There's a factored form on this one, and that may come in handy. Okay, but I'm going to plug in a 0 here. I get a 2 on the top, and I get a negative 9 on the bottom. So I get negative 2/9. What happens if I try and set this whole thing equal to 0? Does it ever equal 0? Nope. So there's only one intercept, and it's a y-intercept. Okay? And the more important part of that is there's not a single x-intercept. This never touches the x-axis, ever. Never touches the x-axis. So let's put this point on here. The only point that we've got so far is this one right here, negative 2/9. And I'm going to have how many branches? How many pieces to this graph? Piece over here, piece in here, and a piece over here. Okay, I'm actually going to have 3 pieces. Okay, because remember, those vertical asymptotes, okay, they're going to break the graph up. It's got a choice. It's either got to go up or it's got to go down. Now, of the 3 branches, okay, and this is why I like these problems. Okay, if you don't go on in math, if you don't get a degree in engineering, in fact, even if you do, I'm not sure you'd see these again. Okay, rational functions are used quite a bit. But I'm not quite sure where you'd see them depending on what you studied. But the logic of this and the thinking that goes into this is really important. So let's think about this for just a second. If this comes in 3 pieces, I think there's one piece that you ought to know what it looks like. You should be able to guess. So let's put these pieces of information together. Okay? It definitely goes through this point right here. So I'm going to draw, don't do this, just watch. Okay? I'm going to draw a little curve, and it's going to come over here, and then it's got a choice. It's either got to go up or it's got to go down. Now, you should know which it is. Which is it? Has to go down. Why does it have to go down? No x-intercept. So it's not this one. It's going to go down. It's going to do something like this. Again, get right close to that vertical asymptote, put an arrow on the end. Okay, over on this side, as we go to the left, it's either got to go up or it's got to go down. Which is it? Got to go down. Why does it have to go down? No x-intercepts. Okay? Now, we got part of the graph here. We're probably about halfway done. Have we really done that much work, or have we done mostly just thinking? A lot of thinking here. Okay? Now, how do I find out what this piece looks like and what this piece looks like? Plug in a point, right? What point do you want to plug in? What point do you want to plug in here? Let's plug in -4, okay? If I plug in a -4, again, this is probably the easiest place to put it. I'd have a 2 on the top, and I'd have a 16 minus 9 on the bottom. 16 minus 9 is 7, so that's going to be 2/7. Okay, the fact that it's 2/7 isn't a big deal. The fact that it's positive 2/7 is a big deal. So what that tells us is if I were to graph this point over here, it would be about right there. It would be at -4, 2/7. And that tells me what the entire shape of the graph is over there. It tells me what that branch looks like. Because remember, it's got to run along here, and it better be which? Above or below? Better be slightly above. So it's going to run along here, hit this point, and then what choice does it have? None. It's got to go up because no X-intercepts. So it's got to look like this. What point do you want to plug in here? Plug in a 4. Guess what you get when you plug in a 4? We get 2/7. So this point right here is 4, 2/7, and this branch has to be run along here, and then it's got to go up again because there are no X-intercepts. Okay? Any questions? 10 points right there. Okay. Now, yesterday when I asked, there were several people that had said they'd seen asymptotes before, or they'd at least heard of them. Okay, so I've got a question for you. Can a graph touch a vertical asymptote? Can a graph touch, or like could it go right across a vertical asymptote? Answer there is no. Okay? Answer there is no. Why not? Why can't it touch or cross a vertical asymptote? Not in domain. Those points, that location of a vertical asymptote or a hole, it's not even in the domain of the function. So you can't plug it in there. You're not going to get a point there. Okay? Can a graph touch or cross a horizontal asymptote? The answer there, Brandon, is yes. Yes, it can. Okay? It's possible. Let's say I were doing this graph right here, and let's say it crossed at this point right here and this point right here. Okay, now this one doesn't. This is an accurate graph for this. But if it goes from here to here, then its choice is to go up here and like that. Okay, so it can cross a horizontal asymptote, okay, usually in the middle. Okay, so not out near the ends. Once it's above out here, it usually stays above. Okay, once it's below out here, it usually stays below. If it's going to cross a horizontal asymptote, it's got to be somewhere in the middle. Okay, same thing with a slanted asymptote. Okay, so vertical asymptotes can't just cross through those. They're not even in the domain. It definitely breaks it into two pieces. Okay, horizontal asymptote, it can cross the horizontal asymptote, usually near the middle. Okay, remember the asymptote is what it looks like out near the ends, down near negative infinity and out near positive infinity. Okay, any questions? Okay, let's look at one that's a little bit more interesting. First question, proper or improper? This is improper. Then the question is good or bad? This one's good. The reason this is good is because the top is the same degree as the bottom. They're both degree 2. So I write y equals, what's the leading coefficient on the top? 2, and on the bottom? 1. So the answer is 2. Okay, that is our horizontal asymptote. I'm going to come over here and I'm going to draw the horizontal asymptote. It looks like this. Y equals 2. So we'll draw that in there and write y equals 2 horizontal asymptote. Awesome. Easy to get and actually tells us a ton of information about this graph. Okay, I want you to look up here for just a second and let's think about what this is going to tell us, and we're going to use this again in just a minute. This tells me that out near the end, it's got to run along this graph right here, this horizontal line of y equals 2. Is y equals 2 positive or negative? Positive, right? So this part of the graph is above the x-axis. So unless we get an x-intercept, is there any way it's going to go down? Nope. Okay, so keep that in mind. That's going to come up again. What's the next thing we ask ourselves? Or what's the next thing we do with this? Okay, we factor it. So I'm going to take out a 2x. I'm going to move this down here. And I'm left with an x minus a 3. Okay, I can factor that. That does factor. I need two numbers that multiply to be -8 and combine to be +2. That's going to be positive 4 and negative 2. Everybody good with that? Okay, does this one look better or worse than the two that we just got done doing? This looks worse, doesn't it? Okay. I think you'll find that this one actually is a little bit more interesting and slightly easier to do. So let's go ahead and finish this. The next thing we do is we identify the issues in the domain. So I can't plug in a negative 4 and I can't plug in a positive 2. Do either of these cancel? Nope. What does that make both of them? Vertical asymptotes. Both of them are vertical asymptotes. So let's come over here and draw the vertical asymptote. I've got a vertical asymptote right here at x equals negative 4, and I've got a vertical asymptote right here at x equals positive 2. Next. Intercepts, right? So x, y, plug in a 0. If I plug in a 0 in the top, I get a 0 here and a 0 here. So the top is a 0, and the bottom is a negative 8. So what is it? 0. Okay? So I know it crosses at 0, 0. I know that's a point on the curve. Okay, the next thing I do is I plug in a 0, or in other words, I set it equal to 0. And remember, to find the x-intercept, use the simplified version or the factored version. Because what's the cool thing about this ugly mess right here being set equal to 0? What part of it do I need to worry about? What's the only part that can make it equal to 0? Just the top, just the numerator. So what's the x-intercept that comes from this right here? 0, and from this right here, positive 3. Now, don't we already have 0, 0? We do, okay? And this one right here would be 3, 0. Okay, now let me talk about something else that this book doesn't talk about and most books don't talk about. What's the multiplicity of each one of these zeros? 1. So does it touch or cross there? Crosses, okay? So it's going to cross at both of them, okay? It's not going to touch it, it's going to cross at both of them. So let me put this other point on here. This other point is 3, 0. Okay, you with me? Okay, so let's take a look at this. How many branches, how many pieces of this graph will we have? Okay, vertical asymptote here, there's going to be one on this side. Vertical asymptote here, there's got to be one in between them. Okay, and then there's got to be a piece over here. This comes in 3 pieces. Okay, now we've done with one with 3 branches or 3 pieces before. Okay, this one, you actually should know what 2 of them look like. Okay, and let me show you why. Okay, remember we said this horizontal asymptote is what it looks like out near the end. So out on the end, it's got to run along here, and then it's got a choice to make. When it gets here, it's either got to go up or it's got to go down. Which is it and why? Got to go up. Why? No x-intercepts. Does that make sense? So this piece has to look like this. Now, if you wanted to plug in, say, a -5 and get a value on here, that would be fine. Okay? Kind of nice if we did get a point like that. But that's what it's got to look like. Okay? Let's take a look at this other piece over here. It's got to run along this asymptote right here, and then it's got to hit this point right here, and which does it do? Touch or cross? Cross. Now, is there any way that it could turn around and go back up? Nope, because that would make another x-intercept, right? So it's got to continue going down. So that point right there, 3, 0, is a point on that branch. It would be nice to plug in, say, a -5 and figure out what that is. Let's figure out this piece right here. Any ideas? Sven? Say that again. Like a positive odd exponent, so it goes like this, starts down here and goes up. How do you know that, though? It does cross, but what if it crossed? We've got 2 choices for crossing, right? Could start up here and go down through that point, or could start down here and go up through that point. You're right, but how could we check and make sure that Sven's right? What do we do, Noah? Plug in a point. Let's say we plug in a -1, or you could plug in a +1 if you want. I mean, pick a fairly small number, one that's pretty easy to plug in. Okay, let's go ahead and plug in a +1. If I plug in a +1 into this, I get a 2 minus a 6. So if I plug in a +1, I get a -4 on the top. And if I plug in a 1 here, I get a 1, a 2, and a -5. So I get a -5 on the bottom. So what's the answer? +4/5. So +4/5 is about right here. So does it cross through going down or cross through going up? Got to cross through going up, and it looks something like this. Again, once it approaches that vertical asymptote, it's got a choice. Okay, got to go down something like that. Okay, so this point is 0, 0. This point is 1, 4/5. And if this were a test, that's probably good enough. It might be nice to figure out what -5, whatever is. Okay, and I would use a calculator to do that. At least a scientific one. Any questions? Okay. All right. Let's keep going then. Go ahead and flip the page over. This is kind of an interesting one. Proper or improper? Proper. That means we've got y equals 0 is our horizontal asymptote. So we can come over here and draw a horizontal asymptote from one end of this graph to the other end. So y equals 0 is our horizontal asymptote. The next thing we do is we factor the denominator. Does it factor? It doesn't. Does it have any zeros? Are there any numbers that we could plug in to make that equal to 0? Does x squared plus 4 ever equal 0? Not with real numbers. Not with numbers that you'd plug in on the x-axis. Okay? So this is simplified. And there are no domain issues. No vertical asymptotes and no holes. No vertical asymptotes and no holes. So this is going to be one continuous piece. Next thing we do is we find intercepts. So if I plug in a 0, what do I get? I get a 3. You get 12 over 4. If I set this equal to 0, do I get any x-intercepts? None. Not a single one. So the only point that I have on the graph at this point is no vertical asymptotes. I've got a horizontal asymptote, and I've got this point right here, 3. How many pieces of the graph is this going to come in? Just one. One big long piece. Does it have any x-intercepts? Not a single x-intercept. So that means this one piece is either all above the x-axis or all below the x-axis. What is it? It's got to be all above, right? Okay, now before you start drawing something or think, my gosh, he's asking us to draw pictures of these really complicated graphs. I've never seen these before. I don't know what this looks like. I'd really like to plug this into a graphing calculator and figure out what it's got to look like. Well, let's think for just a second, okay? It goes through this point right here, right? Okay. Let's say it does something like that. Okay, now I'm not sure if it does, but I do know this. Out near the end, out near the right end, out near positive infinity, if I plugged in 4,000, it's got to be really close to this horizontal asymptote. It's got to run along here. Okay? And then somehow it's got to get up here and hit this point right here. Now, maybe it does this, maybe it continues going up, but at some point, what's it got to do? It's got to come down like this. Now, can anybody tell me something about this function with regard to symmetry, odd or even? If you plug in a -x and square it, don't you get exactly the same thing? So it's got to look the same on the left as it does on the right. So if it looks like this over here, it's got to look like that right there. And if we labeled that point 0, 3, now are we sure this is what it looks like? Let's say I gave you this problem on the test and I said, if you get this right, you get 100% and I'll give you $50. Let's see, that's only like $1,000 for this class. I don't have that kind of money. How could you make sure that this is the right shape? Up. Yeah, let's plug in another point. Let's plug in a 1. If I plug in a 1, I get 12 over 5. I get 2 2/5. 1, 12 over 5. It's a little bit smaller than 3, right? In fact, the bigger number I plug in, doesn't this fraction get smaller and smaller and smaller? So if I plug in a 2, this is going to be, well, let's see, that's going to be 8. That's going to be 12/8. That's going to be 3/2. So that's going to be at 2, I'm at 2, 3/2, 1.5. And don't I know those points on the other side also? Wouldn't just the x-coordinate change to a negative? So is that pretty convincing evidence that it doesn't go up over here? It's got to go down just kind of gently like that. Any questions? That is what it looks like, by the way. That's a pretty darn accurate graph. Okay. All right. Perfect. We've got 2 problems left, and we've got about 15 minutes. Okay, so let's take a look at this problem right here. Okay, now, first question is, proper or improper? Which is this? Improper. Good or bad? This is the bad type. Okay. Now, it's the bad type because we have to do long division, and we're going to get y equals whatever the quotient is. So I'm going to write x plus 2 out here, and I'm going to do x squared, and I'm going to be careful not to make a silly mistake like some people did on the test. I'm going to put in a 0x and then minus a 1. And then I'm going to think, what do I need to multiply x by to make it an x squared? And that's an x. So this is going to be x squared and 2x. Then I'm going to subtract. So this is a minus 2x minus a 1. And what do I multiply x by to make it a negative 2x? A negative 2. Now here's the cool part. Everybody watch, please. This isn't that bad. That's it. That's the quotient. That's what we're after. If you want to continue dividing and figure out what the remainder is, be my guest. Okay? But this right here is the quotient, so this is our, not our horizontal asymptote. What did we call this again? Slanted or oblique. Okay? Now, just for the heck of it, I'm going to go through and do the multiplication. So this is going to be a minus 4, so that's going to be a plus and a plus. So the remainder's 3, right? Okay? So we could rewrite this as r of x equals the quotient plus the remainder over the divisor. You don't have to, okay? You don't have to, okay? All you need is just the quotient. The quotient is going to be the slanted asymptote. So the slanted asymptote is a line that crosses the y-axis at -2 and has a slope of 1. So we're going to cross right here and have a slope of 1. So it's going to look something like this. So I'm going to write y equals x minus 2. I'm going to indicate that that's our slanted asymptote, so I'll use an SA for that. Okay? And let's pause and think for just a second. Here's why I like slanted asymptotes. You ready to listen? I'm hoping this makes sense. Because this part of the graph is above the x-axis, and this part of the graph is below the x-axis. So I already know that the graph starts here and heads up along this line, and then maybe if we hit a vertical asymptote, we've got a choice to either go up or down. And the same thing here. I already know that the graph starts out above the x-axis. I don't always have that. So slanted asymptotes are actually pretty nice. They're a little bit of a pain to get, but they're not that hard to use. Okay? The next thing we do is we factor everything, right? So I'm going to write this as r of x equals x minus 1, x plus 1, and the denominator is still x plus 2. And the reason we factor that is we want to figure out where are the domain issues. Where are the numbers that I can't plug in? What can I not plug into this? A negative 2. Does that cancel? No, it doesn't. So what is it? Vertical asymptote. So we've got a vertical asymptote right here. So I've got a slanted asymptote and I've got a vertical asymptote. So I'm going to put a vertical asymptote right here. Big, long, dotted vertical line. At x equals negative 2, there's the vertical asymptote. What do I do next? I need some intercepts, right? So I'm going to do x and y intercepts. If I plug in a 0, first of all, can I plug in a 0? Yes, I can. I can plug in a 0. If I plug in a 0, I get a negative 1 on the top and I get a 2 on the bottom. So what do I get? Negative 1/2. Okay? If I set this equal to 0, and again, we use the factored form or the simplified form to do that, I'm going to set this equal to 0, so I'm looking right here. When does this equal 0? When x is 1 and negative 1. So 1 and negative 1. Now, I'm going to come over here, and I'm going to plot those points on here. I've got a point of 0, negative 1/2, so about right there. I've got a point of negative or 1, 0 right there, and I've got a point of negative 1, 0 right there. I don't have any other points on here, but I do know this. I do know that out near this end, it has to run along this slanted asymptote, so it's got to run along here. It's got to get to this point right here, and it's got to which? Touch or cross? Cross, because it's an odd multiplicity. It's got to hit here, and it's got to cross. Now, I can wonder for about a half a second about whether or not this goes up or whether it goes down. Which is it and why? It's got to go up because it can't have any other x-intercepts, and we know that it crosses through right there, right? So it's going to look something like this. Again, make it hug along that vertical asymptote. Now, I don't have any points over here. None. But I should still know what it looks like. Because it's got to run along here. And is there any way that it could do this? Nope. Same reason, no x-intercepts. So that piece has got to look like this. It might be good to find this point right here. That point would be negative 3 comma something. If you plug in negative 3, it will tell you what it is. Let's see, I believe it ends up being, let's see, we get an 8 on the top and we get a negative 1 on the bottom. So it ends up being negative 3, negative 8, I think. Is that right? Okay. Any questions? Okay. I have a thought question before we do the very last one. Last one's right here. Hopefully that's not too terribly bad. I definitely know how to do that one. The thought question here is, why do we get to ignore this right here? Why in the end, why on this end and on that end right there, why does it end up looking like the line y equals negative 2? Why do we get to ignore this and say, you know what, don't even need to worry about this right here. It looks like that line. Can anybody look at the remainder or that part of this and tell us why we might be able to do that? Is this, yeah. You are correct. This part right here has more control. It's more relevant as we plug in larger and larger numbers. Okay, but you're onto something here. But why is it more relevant? Why does this determine more of the shape? Why does it look more like a line than a curve there? Yes. Because it's faster. It grows faster. It has more to do with the shape. Take a look at this right here. Is this proper or improper? Every remainder is going to be proper, right? What does proper turn into when we plug in really big numbers? 0. Proper has a horizontal asymptote of y equals 0. So it looks like this, and then add essentially nothing. Okay? Think about that for a while. I don't think you'd ever be asked a question like that, but it's a really good thought question. Okay? And let's see if we can finish this one up. Brandon, what's the first question? And which is it? Improper on this one. Okay. Noah, what's the next question then if it's improper? Not on this one. If it's improper, okay. So then the question is it the good or the bad type? It's the good type right here. So it's going to be y equals, what were you saying, Noah? Leading coefficient over leading coefficient. So y equals 1 is going to be our horizontal asymptote. We got that piece. Hop, what's next? What do we do next? Factor it. Very good. So we're going to factor the numerator and the denominator. So we're looking for numbers that multiply to be positive 4 and combine to be negative 5. What's going to do that for us? Lynn? Negative 1 and negative 4 on the top. And we're looking for numbers that multiply to be negative 4 and combine to be negative 3. Miranda, have you got those? Whoops. That does it, right? Okay, Jordan, what numbers are not in the domain? What numbers do we have to throw out? 4 and negative 1. Okay, and Tony, do either of these cancel? The negative 4 one does. So what does that make x equals 4? It means we've got a hole in the graph right there. And let's see, Tammy, what happens at x equals negative 1? What is that? Vertical asymptote. Okay, so let's go ahead and draw those. Do you need something? Okay, so let's draw a horizontal asymptote of y equals 1. So y equals 1 is our horizontal asymptote. We've got a hole at positive 4. How do we indicate we've got a hole there? What did I say about that? Short dotted line. Thank you very much. So we've got a hole right there. And then we've got a vertical asymptote at x equals negative 1. So x equals negative 1 is our vertical asymptote. Okay, let's see. We are at Hope. Hope, what do we do next? Plug in points. And which points are we most interested in? Yeah, okay, so we're interested in the x and y intercepts. So I'm going to plug in a 0 for x, and that's going to find the y-intercept for us. Where's the easiest place to plug that in? You could plug it in right here and find it. We could also use the simplified version. The simplified version is x minus 1 over x plus 1, right? If you plug a 0 in, you get a negative 1 over a positive 1, so you get negative 1. Okay? And then we also want to find the x-intercept, so we set the whole thing equal to 0, again using the simplified version. So Peyton, what's the x-intercept on this one? It's positive 1. Very good. So let's go ahead and graph this. Let's see, we've got 0, negative 1. Got that point right there. We've got 1, 0. Got this right here. And here's the awesome part. This is the last one. This looks like a really complicated one. Do we need to pick any other points to figure out what this looks like? I see some shaking heads. No, you don't. Now, we could label some other points, but we know what shape this has. Out here, it has to run along the horizontal asymptote. And when it approaches that vertical asymptote, it's either got to go up or go down. Which is it? Y. No x-intercepts, so it's got to go like this. Okay? Let's do this one right here. Runs along the horizontal asymptote. What happens right here? What's that little dotted line to remind us of? Got a little hole. So we're going to put a little hole here. What does it do when it gets right here? Crosses through because of multiplicity. Hits this point right here. Is there any way it could turn around and go back up? Nope, because there's not an x-intercept right there. So that's what it looks like. So let's label this point right here 1, 0. This would be 0, negative 1. And the only other thing that we'd want to do to make sure we've convinced somebody we know exactly what we're doing is maybe plug in this point right here, plug in a negative 2, find the y coordinate that goes right there. Okay? Any questions? Okay. I think you'll find the homework easier than the ones that we've done in class. None of them have holes. Okay? They're all pretty straightforward, and some of them are already factored for you. In fact, most of them are already factored for you. Okay? Send me an email if you've got questions. I'll take a few questions at the beginning of class tomorrow, and then we'll cover 2.7. Okay? Have a great day.